Yes, Upasana, Meera, am I audible?
Yes, ma'am,
Yes.
you're audible.
Okay, so this was the homework that I gave you. I've checked and I've reshared the sheets. So rest of the questions were right. I think both of you had a doubt in this question 10.
Yes, ma'am.
Yeah, let me discuss this. So it's from your previous year only. See, it says that a square loop of side 20 centimeters. The length is given as 20 centimeters. And the resistance of this is 1 ohm, is moved towards the right with a constant speed V0. The right arm of the loop is in uniform magnetic field. The magnetic field given is 5 Tesla. Field is perpendicular to the plane of the loop and is going into it. That we can see from the figure also. The loop is connected to a network of resistors, each of value these. What should be the value of V0 when the current flowing is 2 milliamperes? So first pay attention class, then you can write it later. Just understand this. First of all, the equivalent resistance. We need to calculate the equivalent resistance here. 4 ohm is connected to 4 ohm. Then 4 ohm is connected to 4 ohm. So basically these two are connected in series. These two are connected. Look, these two are connected in series. They are joined by the single wire. So when you're talking about the equivalent resistance, 4 plus 4 gives you 8. R1. R1 gives you 8. Similarly, R2 gives you 4 plus 4, 8 ohms. These two are connected in series. These two are connected in series. Then their resultant is connected in parallel. So finally, R equivalent will be 8 divided by 2. That is 4 ohms. Now see, how can I write this circuit as? How should I write this circuit as? If I have 4 ohms here, so basically I have a resistor of 4 ohms here. This is connected. Now, instead of the whole thing, which kind of EMF am I getting? As soon as we see the loop is moving, it means this is motional EMF. So whatever will be the EMF, it will be BLV not. So I'm replacing it with this resistance, with this battery, and resistance is 1 ohm. And like this, I can write this circuit now as this. Now one thing, this 4 ohm, we have to use this resistance also. So total resistance that will be, the final resistance of the circuit will be 4 plus 1, that is 5 ohm. Right, it will be 5 ohm because 1 ohm will be added to it. So we know the resistance now. We know the current also. What will be the voltage? Current divided, see, we need the resistance. We need the voltage. So current into resistance, we have the current also. So voltage will be 2 into 10 to the power minus 3, 2 milliamperes into 5. So what it will be? This is 10 to the power minus 2 meter per second. This is the velocity. So, so this is the, voltage that you have. Now, your voltage is equal to the motional EMF right now. So your BLV naught is equal to this value only, 10 to the power minus 2. I've written meter per second. This is voltage, volt. So this much. What's the magnetic field? 5. Okay, we could have placed it like this only. Length is 20 centimeters. 20 into 10 to the power minus 2. V naught, we don't know. This is 10 to the power minus 2. So 10 to the power minus 2, 10 to the power minus 2 gets cancelled. Right, that 5 would have also got cancelled directly if we have used. So 100, it's written, yes. So V naught is 1 by 100 meter per second. So 1 meter per second, 100 meter per second, these are incorrect. So this can be written as, speed can be written as 1 centimeter per second. Same thing. So second option. Got it?
Yes, ma'am.
Just quickly write it. Then I'll start with self-induction.
Done, ma'am.
Done, ma'am.
Okay, can you see this screen, self-induction one?
Yes,
Yes,
ma'am.
ma'am.
Okay. So in the last class, we stopped at this question and we couldn't start with induction. We were on motional EMF only. So let us start with induction. Self-induction is what? See, we studied that in what is electromagnetic induction basically. Whenever the magnetic field changes, there is a change in the magnetic flux due to which we have the induced EMF, right? So when I have a single coil and the magnetic field of this coil is increasing or decreasing, changing, so flux of this coil will only be changed and EMF will only be induced within this coil only. So when in the same coil you have the change and you have the induced EMF, we call this as the self-induction. You just require one coil here. One coil is enough. So property of coil due to which in coil it opposes in its own magnetic flux. Property of coil due to which change in coil opposes change in its own magnetic flux. So flux is directly proportional to current. Here a constant term comes. This is coefficient of self-induction, or we also say this as self-inductance. Self-inductance. Unit is Henry. Now, for a solenoid, remember the formula. L is equal to mu naught, N square by L square into AL. So, N square by L square means small n. What is small n? Number of turns per unit length. Per unit length. And when we're talking about capital N, it is just the number of turns. And L is the length. So that is only written. And see, area into the length will give you the volume. So if volume is given directly, use it. If not, then use area into the length for a solenoid. Area means area of the cross section. This one circle, one coil, area of cross section. And length means the entire length of the solenoid. So this is like this. This will be the entire length of solenoid. And this, when you see one circle, this is the area of cross section. Coming to the energy, energy is half Li square. Power is minus Li di over dt. These are the things that you need to understand. Okay, this is something for your exclusively for your JEE exam. Question can come from this, and this is not a part of your board exam. This is a differentiating question, and in advance also the questions have come from this topic. So in mains also it can come, and questions have been asked. So what is LR charging circuit? LR means basically you just have the inductor and the resistor put together. We'll see this in AC also. So time constant means time only. Even if you see the unit is seconds only. SI unit is seconds only. So it's right now, just do not go into the details how we have the exponential function and all. The time constant, this tau is time constant, is L by R. L is the self-inductance, R is the resistance. Now the equation of charging when the circuit is getting charged. You know what is charging? We did it in current electricity. Equation is I is equal to V by R, 1 minus E to the power minus RT by L. I'll just mention this. This is written as R small t by L. L is self-inductance, R is the resistance, T is the time instant. And this one is minus T by tau. Same thing. From here, if I write the formula, it will be tau only, right? 1 by tau, this time constant. So it is written in terms of this time constant, just in case if it is not visible. One question that came was at steady state current, what will be the value of the time? So remember, at steady state, the time becomes infinite. So steady state basically means, see, the current gradually increases and then it abruptly increases. This is the exponential equation. The current exponentially increases as soon as the circuit is switched off. So a lot of details are there in this right now. I think it's sufficient if you remember these equations, and more or less your log table will be required in order to solve it. So values will be simple. So when you switch on the circuit abruptly, when the current increases due to charging, it gives you a graph like this, which is an exponential equation because the graph obtained is exponential. So this equation is obtained. Then similarly, you have the discharging condition also when the circuit is discharged. So time constant will remain the same. This is the same time constant. Don't be confused with torque. This is not torque. Symbol is the same. This is time only. Unit is seconds. For discharging, that 1 minus goes off. So e to the power minus RT by L. R by L can be written as tau, means 1 by tau. So minus T by tau. So these equations are easy to remember. Do one thing, rest of the parts you have, and you will get the PDF also. Magnetism, did you receive?
Yes, ma'am.
Okay.
Yes,
I'll
ma'am.
share EMI also today. EMI, see you have the test also tomorrow. So write down these equations, these two equations for charging and discharging. Then we'll see questions.
Done, ma'am.
Okay, let's see now a question. This says that as per the given figure, if di over dt is minus 1 ampere per second, it says then the value of VAB at this instant will be. Now see, it's like more a question more of a Kirchhoff's law. This is from a 2023 paper. See, voltage here, we have to find out VAB, means the voltage across this. Whenever VAB written or anything is written, like in relative velocity also, if you write VAB or something, that means VA minus VB. So when the question says VAB, this means you have to write VA minus VB. So let's start moving across this. See, this will be VA. Write the equation. This will be VA minus. Now this is moving from the positive terminal to the negative terminal. So current is 2, resistance is 12. So it will be 2 into 12 because it is from positive to negative and we are also moving along. Yes. So when this is current is 2 amperes, resistance is 12. So you multiply, this will give you the voltage across this. Come forward. Now you have inductor. So for the voltage of the inductor, we are going to use L di over dt. That's why this di over dt is given. So this will be minus, because again you're moving from the positive to the negative terminal. This will be minus L di over dt. So let me write down this as IR only. Then I'll put the values. I into R minus LDI over dt. Then this is, see, this is the positive terminal. This is the negative terminal. We are moving from positive to negative. So minus 12. Then minus VB, this is equal to 0. Now we have all the values to solve this question. See, what will it be? VA minus 2 into 12. This will be minus 24 minus LDI over dt. So minus C, minus 6 minus 1, right? Minus 6 into minus 1. Current is also minus given, minus ampere per second. Minus 1 ampere per second. And then minus 12 minus VB. So from here, VA minus VB is 24, 12, 12. Here you have minus 6 into 6, that is plus 6. So 30, 24 plus 6, 30. 30 volt is the answer. Got it?
Yes,
Yes,
ma'am.
ma'am.
Just write down this question. One more question before transformers.
Done, ma'am.
Okay. Let's see the next question. This says the time taken. This is a question from your 18th March 2021 shift 2 paper. This is the time taken for the magnetic energy to reach 25% of its maximum value. As soon as you see magnetic energy, inductor is present or not, just check. Inductor is present, half Li square. Your formula that you have to use is half Li square. So energy to reach 25% of its maximum value when a solenoid of resistance R and inductance is connected to a battery, means this is your RL circuit. Okay. So here we have to use the application of the discharging and charging equation, right? So this is simply charging because it is connected to a battery. It is not disconnected. So as soon as anything becomes connected to battery, you know this is charging. First of all, let us see the relationship between the current. How will you be able to calculate the current? What do we have to calculate first of all? Okay, L by R, these This we have to calculate. See, formula is half L I square, right? So when we say half L I square, it is saying 25% of its maximum value. Maximum value is half L I square. So 25% is quarter of cent, means 1/4. So this will be 1/4 of half L I. Maximum means peak value, I naught square, right? So from here, half L will be cancelled. I will be equal to I naught divided by 2. Got it? This value, the time taken for the magnet, we have to find out the time taken. That we'll calculate later. First check. It is saying the maximum value of the solenoid when it is connected, means it is charging. So we require the current, right? So what's the value of current? The equation that we saw, I was equal to I naught 1 minus e to the power R T divided by L. Now we have, instead of I, we can write this as I naught by 2. This gets cancelled, I naught gets cancelled. So what is left here? See, when this 1 will go, so it will become half. So e to the power minus RT by L is equal to half. So when you take the log of it, this will be log, see, this will be log 2. This here, this will be plus, right? So this will be here log 2, L, this one, A option. It will be first option, see? If you take here, let's put log here, log 2, R can be divided here, and you have the time present. So, sorry, time will come here, L will go there. See, when we put it, RT by L, so L will go here. Look, this is equal to RT by L, right? So L will go here, R will come here. So time constant, this is L log 2 by R. So this is A option. Got this?
Yes, ma'am.
Yes, ma'am.
This is an important question. Mark it, revise these kinds of questions. I'll give you in the homework also. Then we'll start with transformers. See, transformers are a part of AC also. So technically, our alternating current will start after this only.
Done, ma'am.
Done.
Okay. Now see, this mutual induction is what? Mutual induction is basically when In one coil, the properties are changing, mean magnetic field is increasing or decreasing. Suppose this is coil 1. Here the magnetic field is increasing or decreasing, due to which the flux is increasing or decreasing. So in the neighboring coil, what happens? The EMF is induced or the current is induced. So this coil becomes your primary coil, this coil becomes your secondary coil. Now, based on this principle, you have the transformers, which are part of your alternating current also, because they involve transformers in the circuit. Now, but that will just be a connecting point for alternating current. Now see, when we are talking about the flux, phi is directly proportional to current. Here also, phi is directly proportional to current. So phi is equal to mi. What is m? It's the coefficient of mutual induction, or you can simply say this is mutual inductance. Mutual inductance. So based on this principle, that in one coil the change is occurring, which is causing the induced current in the second coil. So this is what is applied in the transformers. So this says property of system of coils in which change in magnetic flux in one coil is opposed by other coils of the system. Or you can simply remember change in one causing the change in another. So you have transformers. Transformers have the same concept. They have a primary coil where you give the input, and the secondary coil you get the output. So they are also of different type. You have shell type of transformers. You have core type of transformers. This depends on how the wiring has been done. Like in the shell type, this is how the transformer is. And the primary coil is like this, secondary coil is like this. Then you have the core type. In the core type, the primary is connected like this. Let's say this is the secondary. And the secondary is connected like this. They are in close proximity to each other. So this is what is the shell type transformer. This is the core type transformer. It's just that here also induction will occur. Here also induction will occur. Proximity is closer here. That is a little at a distance, but the working is same. So it just depends upon what applications are used. Now you have to remember, not these, you have to remember the step down and step up transform. If the transformer converts lower voltage into higher voltage, we call this as a step up transformer. If it converts, see, it's like step up, you remember like this, you are climbing up the stair. So you are going up from lower to higher, step up transformer. In step down transformer, higher voltage is brought to the lower value. That is step down transformer. So it's like you are coming down to the stairs, downstairs, you are coming downstairs. So from higher value, you're coming to the lower value. This is the setup for step down, step up. Number of coils are more in the primary in step down. So this is a point that you have to remember, and they are more in the secondary in the step up. This is a point that can come in the statement based questions. Then yeah, this formula is sufficient for the transformers. See, remember, voltage will be directly proportional to number of turns, and they will be inversely proportional to current. Means primary coil's voltage, the number of turns of the primary coil, they'll come together. And voltage of the secondary and number of turns of secondary, they'll come together. But where you have primary, current is secondary. So Vp by Vs is equal to Np by Ns is equal to Is by Ip. S means secondary, P means primary. And see, efficiency is how much power you have given. Is it giving you the exact output or not? Like if we talk about ideal cases, in ideal cases, the transformer gives the exact value of power what you have given. That is called an ideal transformer. Input power is output power. But in reality, when you use machines, when you use transformer, whatever power you are getting, you will not get it as it is. Some amount of heat is dissipated, some amount of internal energy is utilized. So every exact power will not be present. So if you want to calculate how much efficient your machine is, how much efficient your transformer is, you use this formula: output power by input power into 100. For power, you use VI, means for primary, this will be the formula. For secondary, this will be the formula. Using that, you can calculate output by input. So for ideal, it is output is equal to input. Now, one more concept of AC generator you need to remember. Flux is NBA cos theta. So basically, in AC generator, there is a coil and the coil rotates. For example, see, this is a coil, okay? This coil, the magnetic field is present. Now this coil will rotate like this. So what will happen? Its area vector will come like this. This is how it will change. Then this will rotate further. So area vector will come like this. Then it will rotate like this. So area vector will come like this. Like this, you will have different values of angles. That's why this cos theta is important here. So E is equal to minus d phi over dt. According to which law? Which law is this? E is equal to minus d phi over dt.
Lenz's law.
Lenz's law is just this negative sign. Faraday's law. This is Faraday's law. This negative sign, that why is it opposing, that is given by the Lenz's law. So E will be, when you put the value of flux into this formula, E will be NA/BA omega sine omega t. Omega means the velocity with which the coil is rotating, this velocity with which the coil is rotating about a fixed axis. That is omega. Angle is what is made between the area vector and the magnetic field. Okay, so what will be the maximum value? NB omega. Now in January this year, the paper had this question: when flux is zero. So basically, I just, instead of writing the question, I made it as a note point, and I have mentioned also. So 29th Jan 2025 morning shifts paper. When flux is zero, remember, EMF will be maximum. When flux will be maximum, EMF will be zero. Just remember this. It can come in the form of question. It has come in the form of question. Okay. Let's do one question on transformer and one question on AC generator. So transformer says that, this question says that a transformer consisting of 300 turns in the primary coil, see 300 turns here, 150 turns here. In the secondary gives output power this. So consisting primary 300, 150 turns in secondary. So you have NP, NS gives the secondary output power. Means P2 is given to you, right? Second one. If current in the secondary IS is given, input voltage and current in the primary coils are what? See, using current is given in the secondary. Current is given as 10 amperes. Power is also given in the secondary. That is 2.2 kilowatt. So first we have to convert it. This is, I'm resharing the screen. Okay, this is lagging. I'm resharing it. Just wait. Just wait. Yeah, this is saying power in the secondary coil is 2.2 kilowatt. So let us convert this. 2.2 kilowatt means 2200 watt, right? So this is the power in the secondary. So power in the secondary is voltage in the secondary into current in the secondary. These two we know. Vs is missing. Vs will be power in the secondary by current in the secondary. So power in the secondary is 2200, right? Divided by 10. So voltage in the secondary is 220. So two options are there, right? It means D cancelled, A cancelled. Now, see, you have the voltage, you just want the current in the next one. So see, use number of turns, use voltage, use any value, because now you have the full data with you. So let's use this because we don't have the power voltage in the primary. So let's use number of turns. NP by NS is equal to IS by IP. This will always be reversed. Whenever you're using current, current will be reversed here. Okay, when you're talking about the voltage, it will be exactly the same as that of number of turns. So NP is 300, NS is 150, IS, current in secondary is 10, IP is missing. So this is 2, this is 5. So IP will be 5. So 220 and it's written 10. 220. See, 220 and 20 amperes, 220 and 10 amperes. Check the calculations. 10 ampere of current is there. This is 300. Primary has 300. Yeah, secondary has 150. Current in the secondary is 10. And primary is. So this will be 5 amperes only. So is there any error here? Power in the secondary gives output. I'll check the options again. Answer will be this only. Because see, the calculations are this. Just check again. Let me check the answer to this question. Please write it. And check if there is any calculation error or not. Okay, class. See, the answer options are right. Look here. This is saying then the input voltage. It is asking us input voltage. And this has written the output voltage. That's a confusion. It means the current here we have to take the primary. This is the primary power that is given. It means if it is saying input voltage and you're getting the power, this means that your primary coil, you're getting the output at your primary coil. So this is the primary. That's why we were getting a different answer. Means the current that has to be taken is of the primary coil. Otherwise, see, then only this option can match. A option would be the answer then. But see, if you go by the values and the steps, if these kinds of questions come, because it has mentioned output power. Output means in the secondary only. So when you write here secondary for the secondary coil, here if you write it for the secondary coil current or secondary, you will get the voltage also for the secondary coil only. So we have this voltage Vs. This is for the secondary coil. right? This is asking us the input voltage. So this is correct. Now using this, we can get the value of V. This gave us the value of Vs. So this is the output voltage, no, secondary voltage, right? So we have Vs with us, but the question is not asking us Vs. The question is asking us Vp. So we have to further use this only. Look, we can use Np by Ns is equal to Vp by Vs, right? Np by Ns is 1 by 2. Vp, we don't know, Vs is 220, right? V in the secondary is 220. So double of it, no, this is 2 by 1. Yeah, 420 we are getting. 440. This is 2 by 1. 2 into 220 we will get. Look, 300 by 150, that is 2, is equal to Vp by 220. So Vp was asked, that is 440. So the answer will be A option. A option. Okay, I calculated for secondary and I stopped, but the question asked for input voltage. So using that, you can calculate for this. Other easier method is directly use the relation 2V I1 is equal to V I2 like this, because it is the ratio is given as 1 by 2. You will get the answer directly. This is 10 amperes. So your primary one will be directly 10 by 2, that is 5 amperes. So these steps will be avoided. This is what you can do to make the questions easier. I hope you got it. I stopped at secondary. That was the mistake that I was doing. I was getting the answer as 220 volt for the secondary. This is right, but we want it for primary. Is that clear?
Yes, ma'am.
Yes. Done, ma'am.
Both of you?
Yes, ma'am.
Let's see a question from AC generator. This says in an AC generator, a rectangular coil of 100 turns. N is given as 100. Each of area 14 into 10 to the power minus 2. N is given as 100. Area is given as 14 into 10 to the power minus 2 meter square. This is rotated at 360 revolutions per minute. Not radian. Radian is not mentioned. This is saying 360 revolutions per minute, not seconds. About an axis perpendicular to a uniform magnetic field, B is given as 3 Tesla. Maximum value of EMF produces, take pi as 22 by 7. So it's a question from 30th Jan 2023's paper, shift 2. See, these kinds of questions are also asked in JEE. This is just a basic formula-based question. Value of EMF is NBA omega, and it is saying maximum value of EMF. Maximum value of EMF, C. When will you get the maximum value? NBA omega, when your cos 0 degree is present, that is 1, right? So this will simply be NBA omega. See, two catches are there in this question. One is that maximum EMF. When we say maximum EMF, this is the formula for it. This is one cat. Second thing is that the unit of angular velocity, if you see the rotation of the coil, it is given as 360 revolutions per minute. 360 revolutions per minute. This has to be converted. Means this will be 360. Now revolutions, if you convert it into radian, you have to multiply it with 2 pi. Right? 360 revolutions are there. So into 2 pi, you will get the answer in radian. Also, it is saying per minute, we want in seconds. So 60 seconds. This will be 12 pi. 6 into 2, yeah. 2 pi, 12 pi radian per second. So now we have the value of omega. We can put everything here. 3 into 100 into 14 into 10 to the power minus 2 into 12. This you calculate and see what's the value coming. And pi also, oh, okay, because 14 was given, na? So see, it is saying take the value of pi as 22 by 7. So 7, this makes it 2. So multiply everything. I'll tell you the answer to this. First, you tell me the answer, because you just have to multiply it. So it's an easy question, formula-based question from AC generator. Please write down this. Tell me the answer. We'll start with alternating current now. Yeah, right. Correct answer. 1584 volt. Right. Please write this.
Done, ma'am.
Okay. See, now starting with alternating current. So see, when you give your board exams, that time the questions on alternating current are tough, right? And alternating current seems a bigger chapter because of the derivations of alternating current. And EMI is a very short chapter with smaller concepts. But when it comes to JEE exam, this is opposite, because in EMI, you have lots of concepts of charging, discharging, which we discussed in a short because we don't have time. It's a crash course. In AC, there is not much difference. Few things are additional to what you study, because the derivations you don't have to do in any ways here in alternating current right now. So the portions are just like formula based for you. So let us discuss this. What is alternating current? See, just by looking at the graphs, you should be able to differentiate. Direct current means the value of current is not changing. Suppose I say this is 5 amperes. So at 0 second, this is 5 ampere. At 1 seconds, it is 5 ampere. At 4 seconds, it is 5 ampere. At 5 seconds, it is still 5 amperes. Means current's value is not changing. The value of current that we took before this. See, what all values we were taking, our current wasn't variable, except for the fact that the discharging and charging equation had time constant. That wasn't a variable current. That was the equation of current to calculate how much it has changed. If you look, current part was remaining the same. We saw the question also, I got equal to I naught by 2. In alternating current, the equations are in the form of sine or cosine, sinusoidal waves, where current is changing with respect to time. This is 0. Let's say this is the maximum value, 5 amperes. If you see at 1 second, the value is different. At, let's say, 2 seconds, value is different. At 3 seconds, value is different. So an alternating current can be defined as a current that changes its magnitude and polarity at regular intervals of time. It repeatedly changes or reverses its direction, which is in contrast to direct current, DC, that flows continuously in a single direction. So direction and the magnitude, these are the two differentiating points of alternating current. Now see, this is how you will see instead of battery. If you see battery, this definitely means this is your DC circuit. So I was saying the differentiating point of JEE mains and your board exams is you will get combination of ACs and DCs in JEE. Whereas when you had the board exams, if a question came from AC, it was completely from alternating current only. So that's a little differentiating part. Rest of it is same, impedance, purely resistive circuit, purely inductive circuits and all. So see, this is how we write the equation of voltage. V or E, if you write E, it will be E naught sine omega t. What is V naught? V naught is NB omega. What we have just studied means the maximum value. Like if you look, see these graphs have a peak value here. This has the highest value V naught or I naught. So peak value is called as the amplitude. Amplitude means the maximum displacement from the mean position. Mean position of the axis, how much displacement has occurred. So this is what is meant by alternating current. Now, VRMS and IRMS. One simple formula in terms of your peak value. When nothing is mentioned in your circuit, like this is a circuit given 220 volt 50 hertz like this. These voltages are the RMS value. RMS means root mean square. See, if you go by this, it says root mean square. But if you get the equations, just do the opposite. First, take the square of your current, I square. First, you will take the square of current, I square. Then you calculate the mean. How you calculate the mean? Because right now your current will be variable. So integral of I square dt divided by time. Average is calculated like this. You had current, you squared it. Then you integrated it and divided it by time. So total current by total time will give the mean value. And the third last is root. So root means square, but you go by square mean lastly root. So this is the value of IRMS. This can be helpful. But I naught and E naught in terms, if you have the peak values, directly write in terms of them. VRMS will be V naught by root 2. IRMS will be I naught by root 2. Okay. So this is how you have to remember. V naught and I naught are what? These are the peak values. Okay, just write down this formula of RMS.
Done, ma'am.
Done, ma'am.
Okay, so let's continue. Yeah, this is very important. Superposition of AC currents. This is completely different and exclusively for your JEE exam. This doesn't even come in the NEET paper. This comes in JEE. If you have two currents and both of these currents are the alternating currents, you can identify the equation I sine omega t, I naught sine omega t. So there's a derivation also for this. See, current is a scalar quantity, though it has direction, but we studied this in current electricity, if you remember, though it has direction, but it's a scalar quantity. So don't think this is the parallelogram law applied. When you have this derivation, there's a small derivation for it that's not needed for you. But when you come to the conclusion, actually it's similar to the parallelogram law. I net, the net current will be under root I1 square plus I2 square plus 2 I1 I2 cos phi. Superposition of AC currents. Now, in superposition of DC currents, let me tell you that first. Superposition, yeah. Superposition of AC and DC means in one wire, you have I1 sine omega t like this, your AC current, and in another wire, I2, this is your DC. So remember, take the DC current square plus AC divided by 2 whole square. AC square divided by 2 under root. This is not whole square. AC divided by 2 square on AC under root. This is the equation of the net current. This is very important. Write down this and first write down this, then I'll show you the AC superposition of only AC. See, superposition of DC, you know, if two currents are there, you add the currents directly in a branch and you know how to find out the current. Your entire current electricity is based on this. But if alternating currents are coinciding, you use that formula. I1 square plus I2 square plus 2 I1 I2 cos phi. If a DC and an AC, they are superimposing on each other, this is what you have to use. Just tell me done, I'll scroll up.
Done, ma'am.
Done?
Done, ma'am.
Write down this also. Superposition of AC currents. AC currents means alternating currents only. This double currents means nothing. It's just that we are in a habit of saying DC current, AC current. This is alternating current itself. So this is similar to your parallelogram law. So you can remember it like this. But remember, current is scalar only. Only scalar which has direction. Why is it not a vector? Because it doesn't obey the vector laws. That's why it is still considered as scalar. For a quantity to be considered under the vector, they have to obey the vector laws with having the magnitude and direction. So that's why, because of one lacking point, current is categorized under the scalar quantities. But this formula is similar to parallelogram law, so you can remember.
Done, ma'am.
Done?
Done.
Now, average power, when you calculate for the entire circuit, it is V naught I naught by 2 cos phi. So average power, and then you have, if you write V naught I naught in terms of the RMS value. So see, it will be V, because we can write this as V naught I naught cos phi divided by 2 can be written as root 2 into root 2. And you know, this V naught by 2, V naught by root 2 is VRMS, I naught by root 2 is IRMS. So from here we have this equation. VRMS, IRMS, cos phi. This is the, from here cos phi is called as the power factor. Okay, cos phi is the power factor. And if you have a condition wattless current means when your cos phi is equal to 1. This condition is called as wattless current. So in that case, when you have to calculate, if someone asks you to calculate the wattless current's value, which is usually not asked, till now, none of the questions have been there, which is asking the wattless current just using the cos phi formula. You use IRMS into sin phi. That will give you the value. IRMS into sin phi. This is it. So write down this point also. This is also unique just for your JEE. Though I'll share the PDF. Still, some things you should write before the numericals. Done?
Done, ma'am.
Yes.
Okay, now let's see the circuits. So when you have a capacitive circuit means a circuit which has only a capacitor present and this variable voltage is present with some frequency. So V is equal to IXC. Here the resistance work will be done by XC. What is XC? This is the capacitive reactance. It's the capacitive reactance. V is equal to I into XC. Now the formula of XC is 1 by omega C. What is omega? Your angular frequency. Omega is the angular frequency. So omega is equal to 2 pi nu. The usual formula of angular frequency is 2 pi nu. So you put it here, you will get this is the linear frequency. Okay, this is the linear frequency. So see, if you see this relation, can you tell me how are XC and frequency related if I plot the graph?
Inverse
XC
relation.
inversely proportional. So what kind of graph do we get in such a case? Hyperbola, right? Hyperbolic graph will be there. XC is inversely proportional because your XC is inversely proportional to angular frequency or linear frequency, any frequency. I RMS will be equal to VRMS by XC. I naught will be V naught divided by XC. Wherever the resistor was doing the function, your capacitive reactance will be doing the function of the resistor. This is your circuit of capacitance. So this is the phasor diagram for a purely capacitive circuit. What you have to remember, current reaches its maximum. See, here it is saying that current reaches its maximum before the voltage by 1/4 of a time period. Basically, this means, see, this is the current. So current is already high. Current has already reached 90 degrees when the voltage has just started moving, right? This is the voltage. So we can say current leads voltage by 90 degree, which is pi by 2, or you can say 90 degrees. So this statement is important for you to remember, which is leading the other quantity. So this is how you get the graph. For the phasor, you can draw it like this also. See, resistor will be fixed like this. Resistor is fixed. For the current, what you can do, or let's remove the resistor. It's not needed here. For the circuit, what you can do, the current will be here, right? Current is leading the voltage by pi by 2. So let's say this is the current, or let's make this voltage. This is the if this is the voltage, then your current, let's say this is the voltage, then your current will be this, leading by 90 degrees. But this has not been asked till now. This is important for you to remember. Then you have inductive circuits. Similarly, whatever was done by the capacitor now is done by the inductor. So this means a circuit which only has the inductor connected to the variable voltage. This symbol, this similarity kind of symbol, this means the variable voltage. So this is inductance. So this is called as the inductive reactance. This is called as the inductive reactance. So voltage will be IXL, XL is omega into L, which is equal to 2 pi nu L. Now you tell me, how are XL and nu related?
Directly proportional.
Yes, very good, Meera. They are directly proportional. So we get a straight line because XL is directly proportional to frequency. So IRMS and VRMS, you can write IRMS is VRMS by XL, I naught is equal to V naught by XL. Now see, one thing that I left there also, power and cos phi will be 0 in your purely inductive and capacitative circuits. Power will have a value in the resistive circuit only. Power 0, cos phi 0. Here power will be 0, cos phi will be 0. So this is how we write the graph. Graphical part you can check. See, when the voltage, when the current is here, means below the axis, this reaches the value later than the voltage. So we can say here, this is the voltage. Voltage leads current by pi by 2 or 90 degrees. This is important for you to remember. Now, what's the summary here? See, for resistive circuit, simple. Use your resistance. V is equal to VR is equal to IR. But here cos phi will have the value 1. Power's formula is I square R. Inductance L is equal to VL is IXL. Cos phi is 0. Power is 0. C is VC is IXC. Cos phi is 0. Power is 0. So this is something important that can be helpful. Now coming to purely resistive circuit, we are not doing this in detail because resistors and all we have studied a lot in the DC circuits also. So the difference is that here you are going to use the variable voltage V naught is equal to sine omega t and all. That will be the difference that will come. This will be the difference, that voltage will be V naught sine omega t. Rest of it will be the same. So everything, see here, voltage and resistance are in same phase. None of them are leading. So you can see it from the graph also. And you can see it according to the phasor also. They are exactly aligned to each other. Then when you combine all these three together, you get LCR circuit. This is resistance, this is inductance, this is capacitance. So voltage here will be VR, voltage here will be VL, voltage across this will be VC. So current is I sine omega t. What you need to remember is V is under root VR square plus VL minus VC whole square. Now whether it's VL minus VC or VC minus VL is determined by the magnitude. Whichever has the higher magnitude you use. If VL is greater than VC, then you use VL minus VC whole square. If VC is greater than VL, then you use VC minus VL whole square in all of these. So when you write it in terms of current, V is equal to I under root R square plus XL minus XC whole square or XC minus XL. So this value is called as impedance. That is the resistance of the LCR circuit. So V is equal to I Z. I is equal to V by Z. Now again, when you have the peak value, you're going to use I naught as V naught by Z. When you have the RMS value, you use IRMS is equal to VRMS by Z. For impedance also, if I'm using this, it means XL is greater than XC. If XC is greater, we are going to use XC minus XL is whole square. So see, we have to use whichever has the highest magnitude. Just subtract, get a positive number. That's it. This is how you need to subtract. This is your series LCR circuit. Yeah. Few things are important here. Tan phi has the formula VL minus VC by VR, which is equal to XL minus XC by R. Cos phi is VR by V. That is, see, current gets cancelled. So you will get the value cos phi is equal to R by Z. This is important. This has come in the questions. Cos phi is R by Z. Then power is VI cos phi. Now, this is important. This relates with the concept of your resonance. See, remember, if your angular frequency is 0, XL is 0, where XC will be infinity, in any way, Z will be infinite, current will be 0. Even if you reverse, if you make omega as infinite, XL as infinite, XC as 0. still Z will be infinite and I will be 0. Because in the formula of Z, it has both XL and XC. So even if one quantity becomes 0, the denominator is 0, it will become infinite. Similarly, it depends on this. This is the differentiating part. This is not very important. Resonance is important. In resonance, two things you have to remember. One is that you get maximum power, maximum impedance, maximum current. Out of all of these, maximum current is important. Second, XL becomes equal to XC. So when XL becomes equal to XC, omega L is equal to 1 by omega C. And as soon as they become equal, angular frequency omega is equal to 1 by under root L by C. From here, your linear frequency is equal to 1 by 2 pi 1 by under root L C. In resonance, Z is equal to R. And if impedance has gone, then you can use your resistance instead of Z. Like current will be V by R. Remember, cos phi here will be 1. Power maximum will be I square R. Where, see, in purely capacitive circuit and purely inductive circuit, cos phi is 0, power is 0. In your LCR circuit and your R circuit, means purely resistive circuit, cos phi is 1, power maximum is I square R. Tell me, the theory part of alternating current is clear?
Yes, ma'am.
Anything you want to ask before we proceed to the numericals, you can ask. See, these superposition parts are important. Like, look at this question. This is saying an alternating current is given by the equation I is equal to I1 sine omega t plus I2 cos omega t. So directly by seeing, so I1 has t in it, I2 has t in it, means when you're talking, both these currents are alternating currents. So it means this is the superposition of the alternating current, right? So see, this is one value, this is another value. These are the two values. Now, once you have to solve these, convert one into another. Let's convert this. This can be written as I2 sine omega t plus pi by 2. Right, because we cannot solve it like this with one cos with another as sine, right? And one more thing, now by this, what do we get? We get the value of phi also. This is the extra one, phase difference. See, if first equation is I1 sine omega t, second equation is I2 sine omega t plus pi by 2. What is the phase difference?
Pi by 2.
Pi by 2, right. So you have the phase difference also. You put it in the equation. See, when you put it, the net equation, I net says I1 square plus I2 square plus 2 I1 I2 cos pi under root. See, this term will be 0, right? Because your cos pi is 0. Now, this net value is for the peak. Remember one thing, this is not your RMS value. Question is asking the RMS current. So your peak current I naught will be under root I1 square plus I2 square. So I RMS will be, how is I RMS related to I naught?
I naught by root 2.
I naught. So I naught by root 2 will be under root I1 square plus I2 square divided by root 2. Second option. This C, right? I1 square plus I2 square to the power half divided, we are getting root 2. So first option, yeah, divided by, got it?
Yes.
Please write. Then we'll see superposition of DC and AC after this.
Done, ma'am.
Look at this question. This is saying AC is given by root 42 sine 2 pi by t into t plus 10 amperes. So it's a question from a 2021's paper. That was also from a previous year only. That was from 2021, this also. See, till here you can relate. I is equal to, what's the equation that we write? I is equal to the equation that we write is I is equal to I naught sine omega t. Omega is written as 2 pi by t. So this equation is still here. This is the equation of alternating current. This extra plus 10, this is your direct current. Because unit is amperes, so it is current, but it is not depending on time, it is constant. That's why, see, now the definition of DC comes here. You should know the definition of DC. 10, it's just written 10. It doesn't have any time in it. Whereas if you see this equation, it is I naught sine omega t. It is depending on sine. So it is combination of AC plus DC. So I told you the formula for this DC whole square plus AC square divided by 2. AC means the peak value of AC. I naught, don't take the entire equation, under root. So this will be, this gives you, by the way, direct value of current. This doesn't give you the peak value. This gives you the RMS value. This formula is for RMS. That formula was for peak. Which formula? That combination of AC. So remember, what is the question asking? Whether RMS or the peak value. So DC is 10. This becomes 10 square. AC's peak value is root 42. So it will become root 42 whole square divided by 2. So that is 100 plus 42 divided by 2 root. 42 by 2 is, so this becomes 11, right? This is 21 root 121, that is 11 amperes. Got it? How to solve DC plus AC?
Yes.
Yes.
Write this. See some more questions.
Done, ma'am.
Done, ma'am.
See, this question says E is equal to 440 sine 100 pi t. L is given root 2 by pi Henry. If an AC ammeter is connected in the circuit, its reading will be. So it's a question from 29 July 2022, shift 1. It is basically asking us the current. Now from this equation, Upasana, you tell me what is the peak value? Peak value of EMF.
E0 EMF E0 sin omega t.
That's the peak value. How do we write the equation?
E is equal to E0 sin omega t. So omega
So just relate what all things are what?
omega naught is 400 peak value.
Omega
I
E
mean
naught.
sorry E naught. E naught
Yeah.
is 400.
400. This is sine. Omega is this TT. So from here, E naught, that is the peak value, is 440 volts. Okay.
Yes.
Now for the RMS value, if we have the peak value of EMF, it has given E. So let us also take this as E only. If E naught is given as 440, then EMF's value, what will it be, Meera? RMS? Yes, Meera.
T divided by root
440 divided by
40
root. This is, yes, this is the
4.
RMS value. 440 divided by root 2. Now, we want the impedance. So see, right now, this is a circuit having only the inductor, right? Because here you just have inductance present. So when resistance is alone, XC is 0, your R is 0. So basically you have to calculate XL. XL is equal to omega L. Omega is 100 pi. L is root 2 by pi. So pi gets cancelled. This is 100 root 2. So very easy. I think by now you can guess the answer also. It will be 4.4 amperes. See, IRMS will be VRMS divided by XL. So IRMS will be, ERMS is 440 by root 2. This is 100 by root 2. Root 2 gets cancelled. 44 by 10 is 4.4 amperes. Got it?
Yes, ma'am.
Yes.
Write it. Then we'll see at least one more device we'll add to this. This was purely inductive circuit. Both of you have written?
Yes, ma'am.
Okay. This question says a 0.07 Henry inductor and a 12 ohm resistor. So this is your LR circuit. They are connected in series to 220 volt 50 hertz source. Current in the circuit plus phase angle between current and source voltages. That is what you have to calculate. You have to find out the IRMS. Current in the circuit means you have to calculate the IRMS and you have to calculate phi. These things you have to calculate. Upasna, you tell me what is the VRMS here?
220 volt.
How much?
220
220.
by
220 volt. That's it.
yes.
See, this will be only 220. I told you with the variable voltage, whatever voltage is given, that is your RMS value only. So it is given 220 volt, 50 hertz. So this is your RMS value only. VRMS is 220. Now, tell me how should we calculate the value of XL? Should we just calculate the value of XL? Okay, Meera, you tell me how should we calculate the value of XL? Just tell me this.
1 by omega L. Omega is 2 pi mu n. 1 by 2 pi mu L.
No.
No,
Check.
2 pi mu L only.
When you
2
have
pi mu L.
capacitance, XC is 1 by omega C. Okay. So 2 pi nu L, because this is omega L, XL is equal to omega L. Omega is not given, linear frequency is given. So XL will be 2 pi into frequency. So that will become 100 pi into L. L is 0.07 Henry. So this will be 22 by 7. Let's take this as 100 into 22 by 7 into 7 by 100. 100, 7 get cancelled. We have 22. What will be the unit, Meera?
Henry. No, ma'am.
XL is doing, yes?
Ohm.
Ohm. It is doing the work of resistance. No? So it will be ohm. Very good. So this is the XL. Resistance is already given as 12 ohm. Upasna, how do we calculate the value of Z? XL and R are present. How do we calculate the value of Z?
E0 by I0 with
But we have to calculate IRMS. That is our task. See, IRMS will be VRMS divided by Z. VRMS is this given in the question. Z is missing. It's a circuit having inductor and a resistor together. This is how the circuit looks like. This is the inductor, this is the resistor. What should be the impedance? See, capacitance is not there. Yes.
R square plus L square, XL square.
Yes. Under root. XL square plus R square. See, if it is LCR, then we take their difference. If it is only LR, we just take XL and R. If it was only RC circuit, then this would have been XC. That's it. So then you can calculate also. See, XL, we have calculated 22. 22 whole square plus R is 12. This is also forming a Pythagorean triplet only. This will be 220, right? 220. No, this won't be 220. This is 22 whole square plus 12 whole square. 144 it is. So this you calculate whatever value of Z you are getting. IRMS will simply just put it here. You will get IRMS. For that angle, phase angle is also asked. Tan phi. How should we calculate tan phi? Yes, anyone? See, remember tan phi is, yes, Upasna, you want to try?
Phi is tan inverse XL by R.
XL by R. Yes, very good. This is XL by R, 22 by 12. Right. So this will be tan inverse 11 by 6. The whole phase angle. Okay. Write it, please. Yes, class, done?
Yes, ma'am.
Yes.
Okay, let's look at this question. A series AC circuit containing an inductor, L is given, capacitor, resistance, driven by an AC source of this much voltage and this much frequency. Energy dissipated in 60 seconds. We need to calculate the energy dissipated in 60 seconds. C class. Formula of energy will be the same as that of heat. This is energy means heat energy. Heat energy, if you remember, we've already done it in the current electricity. It is I square RT. Remember, we did this in current electricity. Yes or no?
Yes, ma'am.
Yes.
So resistance is given 60, time is given, current is missing. So IRMS, we need to first calculate. So again, for IRMS, it will be ERMS divided by Z. ERMS is also given directly, 24 volts. Yes, Upasna, 24 volt is the EMF, ERMS or not?
Yes.
Yeah. So it means we want to first we have to calculate the value of Z. Then rest of the things can be solved. So for Z, we first require the value of XL. This you tell me, Upasna. How to calculate XL in this question?
Omega L. So it's
How
2 pi
much?
omega L. So it's
Okay, is omega given?
2 pi nu L.
Yes. 2 pi nu. So 2 into pi, I'm putting frequency is 50. L is 20. Millihenry means divided by 1000. This much of ohm is XL. XC, Mira.
1 by 2 pi mu c.
1 by 2 pi nu c. So this will be 1 divided by 2 into pi into 50 into 120 microfarad is given. So 120 into 10 to the power minus 6, this much of ohms. Resistance is directly given as 60 ohms. Now, Upasna, you tell me what is the formula for impedance here in this case?
Root of R square plus XL minus XC the whole square.
Yes. So see, this value you have to check whether XL is coming out greater or XC is greater. I don't remember the values. When you will check, just XL minus XC, XC minus XL, make that. Under root, put the value of Z from here. ERMS is already 24 volt. Once you have the value of IRMS, what will be the energy? Energy will be this IRMS whole square into resistance is 60 into time is 60. So this you write it, calculate, I'll tell you the correct answer. See if any of the option matches. Quickly do this. Okay, class, you can solve it. Did anyone get any answer? It is lengthy. This question is lengthy. Though the 50 hertz and 2, they make it 100, but value of pi and all is a little lengthy. See, answer is 5.17 into 10 to the power 2 joules. Okay. So just mark it and cross check whether you're getting this or not. See, once you will get 5, the issue is that both the options have these 5. So you have to have the accurate decimal value because the rest of the things are same. Just a difference of 6, 5 and 1, 7. Otherwise, these options are completely different. Right. So this you have to properly solve. Yeah, it was a lengthy question. So let's come to the last question for today. This question is from your 27th June 2022. Okay, shift, a first shift. All right, first shift. This was a question from that. So it says a 220 volt, 50 hertz AC source is connected to 25 volt, 5 watt lamp. Now, one thing, if you have studied current electricity properly and you have revised it, you won't have difficulty in such kinds of questions. We have practiced these a lot there. This is a variable. Now, it's just that this is variable. Upasana, which voltage is this?
ERMS.
Yes, VRMs, right. This is VRMs. This is lamp. This is saying 25 volt and 5 watt. Okay, and it is saying 220, 50. We have done. It is connected to this resistor R, this one, missing one. And it is saying to run the lamp at its peak brightness, the value of R. Basically, we need to calculate the value of R. So simply we have done these questions in current electricity where one of the resistance was missing. It's just that here, the resistance that you will be equating will be the impedance, right? We'll not be using the simple resistance. We'll use the impedance. First of all, whether it's the question of current electricity, any chapter it is, as soon as you see bulb, I have told you make and convert it into a resistor so that you treat it normally as a resistor connected in series. Remember in current electricity, we saw multiple questions where I have I made you write the separate heading of home appliances also. So see, V is given, P is given. Resistance will be V square by P. Voltage, this is 25 whole square divided by 5. 5 into 25, that is 125 ohm. So basically you have two resistors connected, one with a voltage 125 ohm, sorry, resistance 125 ohm, second with resistance R. So this is here the resistance till now, but we want the equivalent resistance of the circuit, that is impedance. For impedance, we require two things, current and voltage. VRMS, as Upasana rightly said, VRMS is already given. VRMS is already 220 volt. So for the equation, Z is equal to VRMS by IRMS. VRMS is already there. We need IRMS. So how to calculate IRMS? You can calculate IRMS from this. Why? Any idea why should we calculate from this and that will help us? Why not separate currents for both of them?
Because they're connected in series.
Very good. They're connected in series. If you have the data here sufficient and you can calculate the current from here. If I amount of current is flowing through this, I amount of current will be through the entire circuit. This is not parallel case question. If it was parallel, voltage would have been seen. Something would have been given other than this. So straight away, you have what all things you have. You have the voltage, you have the resistance, you have the power. Let's calculate the power. So power will be C, I square R simply. Power is given as 25 I square. Resistance we have calculated 125. So I will be 1 by 5 amperes, right? So what will be Z now? VRMS is 220 divided by 1 by 5. 5 will go up. Impedance will be 1100 ohm. Now, Upasana, you tell me. This is the impedance. Total impedance means the net resistance. What is it equal to? How should I write the net resistance equal to? What's the equivalent resistance here? Equivalent resistance.
Can you repeat?
See, the equivalent resistance of this entire circuit is 1100 because that is the impedance, right? So when you have the total resistance, when you have to calculate the total resistance, how do we calculate? Two resistors are present. How do we calculate the equivalent resistance?
R1 plus R2.
R plus 125, right? This R plus 125, which is equal to R equivalent. 125 plus R, which is equal to R equivalent. This is ultimately what? This is equal to R equivalent. This time your R equivalent is Z. So 125 plus R will be 1100. So R will be 975 ohms. Got this question?
Yes, ma'am.
Okay, one more question is left. I thought only 6. Write it. This question let's discuss. Just let me know done. One question is left. That's a very short question on resonant frequency. Just tell me when once completed.
Done, ma'am.
Okay, let us just, this is the last question, question 7. See, this says find the peak current and resonant frequency of the following. So resonant frequency has one simple formula, 1 by 2 pi, 1 by under root LC. So this will be 2 into 3.14, 1 by. L is given as 100 millihenry. So this will be 100 into 10 to the power minus 3. This is L. Capacitance is 100 microfarad. This is C. So 100 into 10 to the power minus 6. This you can solve. Whatever frequency will come will be the answer. So this you have to check. I'll tell you the correct answer. This is the frequency. For the peak current, Upasana, you tell me from this equation, what is the peak value of voltage?
30.
30, right. Very good. V is equal to V naught sine omega t. V naught means the peak value. This is the peak. So V naught is 30 volt. Why we are not focusing on any other thing? Why only V naught? Because it is saying peak current. For peak current, I naught, you require V naught by Z. Now, Meera, tell me what should be Z in this question?
Resistance, because
Yes,
it's
very good. 120. Because it is resonant condition. In resonant, the value of R is equal to the value of Z. So I naught will be equal to 30 divided by 120. That is 1 by 4 amperes. So 0.2, check it, 100 or 50, whatever it is. I think it will be 100 or just check. I'll tell you the right answer. First, write it. This question is clear? How have we calculated?
Yes.
So that completes with alternating current. Now EM waves are left. EM waves will just take half an hour. Many things in EM waves you have to remember by yourself. The spectrum that I'll give you. I'll give you the material for that. Tomorrow, sir will be taking the class. I told you you'll have a class on Friday. So sir will be taking your electrostatics portion. Whatever portion has been completed till today, everything will come from the first day. Vectors from sir's portion, vectors, electrostatics to whatever he has completed in the class, that part. The current, electricity, magnetism, EMI, AC will come from here. I'll share the homework also of alternating current and inductance that you solve. So it will also give you a help for the tomorrow's exam. Just tell me done.